Hello, this is Joshua Hale's Data Structures Assignment 5 screen recording. I'm going to walk you through the compilation of my project. You will see in the directory that you will have these 5 files, and to compile it, all you have to do is type make. This compiles it into an executable called hash, which you can run /hash. It will ask for a word, and I can type in something like setnance, and I misspelled it obviously, and it will query the hash table that I constructed out of the dictionary file and determine which word it is similar to that matches the same first letter, and in this case it is sentence, and I will say yes, or I could say something different, and it will be like, I didn't understand that answer, please type yes or no. So I do mean sentence, I say yes. And then when you type yes, you will also see the other words that share the first 2 letters with it. So if I run it again and I type in something like use, and they detect that word, and it'll also display US. Now if I type in something that it does not have a word for, like xylophone, it will just say false. I can also run it for something like lop. It can mean, do you mean look? And I'll be like, yes. And I'll also display long with there, so on. Works great. If I look into the code, all it is main.cpp. I import these things for file input, keeping track of, actually I don't use list, so that's nice. So that's convenient. Yes, I also, so this is the hash table class. You get these functions that construct the hash table, can display the hash table, can spell check the hash table, and internal methods for the actual hash function, finding the similarity between words, and I have this unsigned int for the maximum size of how the amount of buckets for my hash table. So I create my hash table called values, and I just make it a string of a certain size. And then I go into it and I'd be like, all right, I set the whole table to be default strings here in the constructor. This is the function that just returns the first letter modded by the maximum size. So every word with the same first letter is in the same bucket, basically. I visualize it by just going through it and printing it out, making sure I don't print anything that doesn't exist. And then every bucket is contained with this, but you don't even see this in the final assignment. I insert by checking to see if it already exists. If it doesn't, then I will find out where it should go, and I put it there. Also, if I run out of space, I will display that the table is too small to fit. I can find specific things by getting the hash function and storing that in the index. And if the hash function returns -1, then it doesn't. Then the input is not useful. But I search for it if it's something other than -1. It usually isn't. And then if I find it, I'd be like, yep, it's in there. But if I don't find it, then no, it is not in there. I remove an element from the table by calling the function. If it's not there, then it's like this value doesn't exist, or it's not even possible, so it's not found. If I search for it, and if I find it, then I clear it and remove it. And let's see. For take input, I will take in a value and then convert it to a more modular value because I need to convert it to lowercase, so that's why it has it as a constant input, but then I turn it into a just default string. And then I just do this neat little thing here that will detect if it's a capital letter, and if it is, it'll just increase its char value so that it becomes a lowercase value. Works great. And then I call find, and then if it is a single letter word, I can't really do anything because all of the finding stuff, this is the input to check if the word exists. So if it does exist, then we return true, but if it doesn't and it's a really tiny word, then you just return. There's nothing you can do with that because we need to use that second letter and more letters associated with it to like actually compare. This is a complicated if statement that will make sure that it prints the words that share the first and second letter, but it won't print the same word again. So this is if we're going down the chain where if it does exist, we found it, and we are just displaying all the other words that share the first two letters. If we can't find the input in the dictionary, this really big else chain happens. In that case, we will try to find where it would go, or mainly we're just trying to find where the all the words that share the same first letter it has. We loop through them and assign a score to them. Oh, first I'm creating a array for similar scores. I find out how many words there are that could possibly be the word in this while loop, and then I use that number to determine how many spots in this array we need to store scores. So then we do we call the similar function that I can skip to. The similar function will take in two words. One of them is the word the user just inputted. The other word is the words I'm looping through trying to find if it fits. And it will set the bigger string to the top so that my ratio is always greater than 1 or greater than or equal to 1. And then I will set the sim score to the ratio because later I'm multiplying the ratio by itself. Well, more importantly, I'm adding specific floating points. I found that 0.5 works really good for this. I check if the letters match. And if they don't, I add 0.5. That means they're less likely. If I check if there is a letter in the bigger word by doing an inner for loop when I'm checking each letter in the smaller word. So if a letter in the smaller word is inside of the bigger word, then it will come back true. And then if it is not, I will add 0.5 to that. So, and the lower the score, the better it is. So that's how I can determine, I loop through all the scores inside of the take input function, and if the lowest one wins, that's the one we decide is the most similar. It works pretty well, especially for sentence and longer words. So that's awesome. And I then store the index of the lowest score, and I store what that score is, and then I can print it out here, but that's not really important. I mean, never mind. Sorry, I used to have a print statement down there, but I have this here to check what all the values are. If I need to debug something, like if I type in sentence and it gives me set instead of sentence, I'm like, oh, I want to figure out what they think all the values are. So that's a very useful print statement. I keep that commented just in case. The threshold, I set all of the initial scores in the array to be 100. They're always set to everything lower than that. There's no way that a word can get more than 100 unless it's a stupidly long keyboard smash. So after we found the most likely word through this for loop, and we stored the index, we can go, do you mean this word at the lowest score index? And if they say no, then we're like, all right, false. But if they say yes, I actually call this function again and pass it the word that that the user just agreed that it was. So if I just said, oh yes, I did mean sentence, it will call this function again, but with the word sentence. So I don't have to repeat code about doing the repeat the words with the same first two letters. So that's awesome. That's very convenient. Also, I have a little user input handling thing here where if they didn't type yes or no, they're like, you got to type the right thing. So it displays that, which is great. Love do while loops for that. And then if this is the outer else where it's like, if you typed in xylophone or something, it'll be like, oh, this does not exist. No similar words. False. So I already talked about the similar. So for main function down here, I went a bit too fast. For my main function, I start the time interval. I have the time interval here. I create the hash table, and then I parse through the dictionary. I use the getLine command inside of the checking if it's open, and I ran into this really annoying error, but luckily, after turning it to lowercase and then erasing all of the white space using this one line thing right here, so convenient. Find last not of, it like deletes everything that's either a space, new line, break, tab, whatever all those things mean. So I copied that from the C++ reference, and I copied this convenient lowercase generator from CS Info. So a couple lines of code that I stole. Sorry about that, but it's very convenient. I then insert this lowercase white space erased word into cur word. I then close the file, and then, or if I can't find the file at all, I'm like, can't be found. So I would print the table here if I wanted to, but that's not for the final project. So I then start the timer, I get input from the user, look for a word, and then If it does not exist, I then will run the take input user in. So all the like logic is inside of those two big functions at the bottom of the class for the take input file and the similar file. So, oh, I also erase the white space of whatever the user typed in. And inside of take input, I also turn it lowercase. Yeah, so that is the screen recording. I also stop it right here, and then I get the interval and display it in microseconds, and that's it. So yeah, I hope you enjoyed. That was my screen recording.